Hi, today we're looking at, we're going to take a look at the product and quotient rules for derivatives. Now, in our last video, we looked at the first big rule for derivatives, the power rule. The power rule, if you remember, you multiply your exponent times your coefficient, subtract 1 from your exponent. So this is the big rule. This is the first of four major rules for derivatives. Okay, that's the power rule. Now today we're going to look at two more major rules. We're going to look at something called the product rule and the quotient rule. Now we also have what's called the chain rule. Now we're going to say that for a later date, but today we're going to kind of be focusing on the product and the power and the quotient rules. Now what I have here is a little PowerPoint to kind of introduce the product and quotient rules. What you won't see is a bunch of examples on this video. Now the next video we'll do a bunch of examples, but today just a couple of minor examples that I can just kind of point to on the PowerPoint and kind of describe and talk about. That's all you'll see here today. But we're going to introduce the product rule and the quotient rules and just one or two little examples and then move on. Now, a couple of essential questions that we're going to look at in this video. First, what is the product and quotient rules for derivatives? Also, how do you find the derivative of trigonometric functions? So we're going to look at the derivatives. Now we already know the derivative of sine and cosine. So in this video, we're going to look at the derivatives of the other four trig functions. All right. Also, what are higher order derivatives? First derivatives, second derivatives, third derivatives. How do you get the derivative of those functions? So let's get started. Let's go ahead and introduce the product rule. All right, get right to it. This is our second major rule for derivatives. All right, so we've already looked at the power rule. This is the product rule. Now the product rule basically involves a function where you have two functions being multiplied together. Right? And let's see how we go about finding the derivative of a product of two functions. And this is how we do it. This is how this is done. Now you got the derivative of f of x times g of x. Now f of x is one function, g of x is the other function. Now to take the derivative, this is how the product rule goes. Okay, you take the first function and you multiply that times the derivative of the second function. All right, so you take the first function and you multiply that times the derivative of the second function. Plus, so plus, we take the second function and we multiply that times the derivative of the first. So the product rule goes like this. The first function times the derivative of the second function plus the second function times the derivative of the first function. Now, we're going to look at one simple example. This is a little trig example that, like I said, we can kind of point to here on the PowerPoint and just to kind of show you how this will go. We're going to see a bunch more examples in our next video. But once again, remember now, never forget the product rule. When you have a product, you're going to use this rule. Unless you can simplify it so that you can just use the power rule. But once again, this is the first function times the derivative of the second, plus the second function times the derivative of the first. So, a little example. Okay, let's do f of x equals x sine x. Now, for a lot of students, they have the hardest part of the product rule is recognizing they have a product. So, as you look at f of x equals x sine x, you've got a linear function x times a trig function sine x. That's a product. So x times sine x. So once again, I'm using the product rule. Remember, first times the derivative of the second, plus the second times the derivative of the first. So see this start off will be x times the derivative of sine x, as we set this up in the product rule. So the x times the derivative of sine x plus the second function, which is your trig function, sine x times the derivative of x. So let's see what we get for our answer now. The derivative of sine is cosine, all right? And the derivative of x is 1. So as we simplify this in, the first term will be x cosine x plus sine x. There you go. It's actually sine x times 1, and then which is just sine x. And that's our derivative. All right, so you end up with a sum when you use the product rule. So the first times the derivative of the second plus the second times the derivative of the first. This is x cosine x plus sine x. Now, sometimes, a lot of times, particularly with polynomial functions and things like that, you're going to have to simplify your expression, but this here, this is it. This is just a little trig function. You can't simplify this. Any further, that's all. So this is our product rule. Let's take a look at the quotient rule. So let's describe the quotient rule. Now, the quotient rule, these are fractions that you cannot rewrite these fractions easily to make a multiplication out of them, to where you could quickly use the power rule. Okay, these are some more complex fractions, and the quotient rule would apply to these types of fractions. And this is how the quotient rule goes. Now, for a lot of students, this is a little bit more involved rule. A little bit more involved than the product rule. The product rule is the first root of the second plus second root of the first. Now with the quotient rule though, if you've taken the derivative of a fraction. Now this will work on any fraction, even the simple fractions this will work, and more complex fractions. But you got the derivative of f of x divided by g of x. So f of x over g of x. All right? Now to take the derivative, this is how the quotient rule goes. First, we're going to take the bottom of the fraction, your denominator, and square it. So the bottom fraction is g of x. I'm going to do g of x squared. Okay, that's going to give us our denominator, our denominator. We're going to end up, now, with the quotient rule, we're going to end up with a big fraction here for our answer. Now, along the numerator, we're going to take the bottom fraction times the derivative of the top. So the bottom times the derivative of the top minus the top times the derivative of the bottom. Once again, you take the bottom function times the derivative of the top minus the top times the derivative of the bottom. Now you got to be very careful with the quotient rule, because in your numerator you got this subtraction, and it has to go in this order. The bottom squared in the denominator, and then the bottom derivative of the top minus the top derivative of the bottom. Now, if you get the numerator reversed, you miss it because of the subtraction. Remember, subtraction you cannot rearrange like you can addition. All right, so it has to go bottom derivative of the top minus the top derivative of the bottom. So that's how the quotient rule has to go. Now, let's look at a little example now with the quotient rule. So we'll do a little trig example. We'll just do f of x equals sine x over x. Now the denominator is x, and your numerator is sine x. So as we set this up now, once again, I'm just going to kind of point to each one of these, and we're going to work some more trig examples later when we get into our next video. But when you set this up in the quotient rule, you're going to start off, the denominator of your fraction is x, so it'll be x squared. So you take the bottom of the fraction and square it. So the bottom of the fraction is x squared in your denominator of your derivative. So as you set this up, so f prime x will be equal to x squared in our denominator. Now, along the numerator, we're going to take the bottom function. Now, the bottom function is x times the derivative of the numerator. So it'll be x times the derivative of sine x minus. So the bottom derivative of the top minus the top derivative of the bottom. All right, so the rest of the expression will be sine x times the derivative of x. Now, let's see what we get. Now you got to simplify these two. So as we go about simplifying these, remember the derivative of sine is cosine. The derivative of x is 1. So as you simplify these, you take the derivative. Once again, this is x squared in the denominator. So the derivative of sine x is cosine x. So the first part of the numerator here will be x cosine x. Okay, minus. Now the derivative of x is 1. So it'll be sine x times 1, or just sine x. And there you have it. That's our derivative. So once again, the bottom times the derivative of the top minus the top times the derivative of the bottom. Okay? So just a little trig function to kind of illustrate the quotient rule for derivatives. And like I said, in our next video, we'll do a bunch more examples. Now, let's go ahead and list the derivatives of the other 4 trig functions. Now, we already know sine and cosine. The derivative of sine is cosine, the derivative of cosine is negative sine. So if you set this up, the first one I want to point out is tangent. The derivative of tangent is secant squared. Right, so the derivative of tangent is secant squared. Now, on our next video, I'm going to show you why this is secant squared, but I'm not going to work it out right here. So we'll go ahead and throw it out here. The derivative of tangent is secant squared. Now, you use this all the time in calculus, all right? So you have to know what the derivative of tangent is. It's another one of these trig functions you got to have memorized. Now, there's 6 of them. Let's go and bring up the next one. The derivative of cotangent x is negative cosecant squared x. So the derivative of cotangent is negative cosecant squared x. Third, the derivative of secant x is secant x tangent x. And then the last one, the derivative of cosecant x is negative cosecant x cotangent x. Now there's two of them we use a lot. And that's this one right here, a little asterisk on that one, and secant. So we use these all the time in calculus, all right? The other two we use somewhat, but not as much as the two in red here. The derivative of tangent is secant squared. The derivative of cotangent x is negative cosecant squared x. The derivative of secant x is secant tangent. All right, so you got to remember that. The derivative of secant is secant tangent. The derivative of cosecant x is negative cosecant x cotangent x. All right. Now, we've already done sine. The derivative of sine is cosine. We said the derivative of cosine x is negative sine x. So those we already know, but this is the other four. So now we know the derivative of all 6 of our trig functions. Memorize them. All right, let's move on. Now, I want to point this out a little, an easy way to kind of remember some of these, and it's a little thing I want to point out, is that the derivative of your cofunctions are all negative. So if you look at them, the derivative of cosine x is negative sine x, negative. The derivative of cotangent x is negative cosecant squared x, once again, negative. And the derivative of cosecant x is negative cosecant x cotangent x, once again, it's negative. So your cofunctions, the derivatives are all negative, the others are not. I just wanted to kind of throw that out. It may help you memorize those a little bit easier. Now, let's take a look at some higher order derivatives. All right, so a little bit about higher order derivatives. First, the derivative of a position function is its velocity. So that's the first derivative. So if you take the derivative of a position function, it's going to give you an expression for the velocity of that function, the instantaneous velocity. Okay, the second derivative of a position function is its acceleration. So the second derivative gives you the acceleration, or describes the acceleration. So when you look at it, so given the position function, s of t, s prime t gives you the velocity. That's going to describe the velocity. That's your first derivative. So the first derivative describes the instantaneous velocity. The second derivative gives us the acceleration. The acceleration is the rate of change of the velocity, so that will describe our acceleration. Now, if you want to find the third derivative is just the third derivative. So nothing really special about that necessarily, but the third derivative is simply the third derivative. Now, let's do this right here. Now, hopefully on your guided notes, if I'm able to do the guided notes for you this time, I'll try to put these in your guided notes so you can see them. But take a look at, this is the graphs of f prime, and f prime prime are shown. Which is which? So which one of these is going to be the graph of the original function? Which will be the graph of the first derivative? Which will be the graph of the second derivative? All right, so here they are. Let's start off with an easy one here. Now, you want to remember, now you got graph number 1, graph number 2, and graph number 3. Now, you remember, when you take the derivative of a function, it's going to be, the degree of the derivative is going to be 1 less than the degree of the original function. Right? And because you're subtracting 1 from your exponent each time. Right? So as you look at our graphs here, let's go ahead and point these out. You've got a constant function with a slope of 0. You've got what looks like a linear function of some type and a quadratic function. Now, a quadratic function is degree 2, a linear function is degree 1, and a constant function is degree 0. So the original function would have to be our quadratic function. So this would be f. So that'll be our original function, will be the quadratic function. The linear function would be the first derivative. So this would be f prime. And the constant function would have to be the second derivative. That would be f prime prime. So once again, as you take the derivative, remember you're subtracting 1 from your exponent. Right? So the highest degree here would have to be the parabola, would be the quadratic function. Okay, that'll be the parabola. The first derivative would be the linear function, and then the second derivative here would be the constant function. Let's do one more of these now, just kind of comparing the graphs, so you can see if we can determine which one is the original function, which one will be the graph of the first derivative, and which one will be the graph of the second derivative. All right, so let's take a look at 3 more. Here they come. Now you got graph number 1, graph number 2, graph number 3. Now, just looking at these, now graph number 3 looks to be a cubic function of some type. Graph number 2 is a linear function. And graph number 1 is a quadratic function. So I know that a cubic function is degree 3, quadratic function is degree 2, and a linear function is degree 1. All right? So the highest degree here would be the cubic function. So the I guess function number 2 here would have to be the original function. That would have to be f. So that'll be the original function. So it'd be cubic, that's degree 3. The first derivative would have to be graph number 1. So that's going to be f prime. So the cubic function is the original function. Subtracting 1 from your exponent would give you degree 2. That would be the parabola. And that's graph number 1. So that would leave us with the linear function here as the second derivative. So the second derivative would be the linear function. And like I said, if you have guided notes, if I'm able to do guided notes, I'll see if I can put these on your guided notes for you to make them, so maybe you can see them a little bit better than you can here on the PowerPoint. Right, and we'll look for the second video that has all the examples and stuff.